Alright, solving inequalities. Number 3. Let's start with 3. There we go, number 1, I'm sorry. Solving inequalities. I'm going to go ahead and graph this one real quick, and then we'll deal with this algebraically. So once again, 1 over x does that. Asymptotes being the x and y axis. This guy here, if we graph the left side, we'd send it forward 2 units. Alright. There's our vertical asymptote. Horizontal asymptotes, no changes. Vertical dilation of 5 by a factor of 5. The graph's going to look something like this. And let's go ahead and make those solid lines. So if we graph the left side, we want to know when it's greater than 0. Graphically, you can see it. So for over here, all the y values are less than 0. They're negative values. On this branch, all the y values are greater than 0. Okay? So to solve this inequality, this one's pretty straightforward. As long as x is greater than 2, 5 divided by x minus 2 is bigger than 0. So at 2, it's undefined. We cannot plug in 2, so we don't know if it's going to be bigger than 0, equal, or whatnot. It's undefined, none of which is happening. If you plug in x's that are smaller than 0 and made a table, in fact, let's go ahead and see what's going on there. So let's pick positive 1, for example. So 5 over 1 minus 2 is negative 5, which is less than 0, and we wanted it to be greater than 0. So when you plug in 1, it does not satisfy the inequality. If we plug in something on the other side, 2, let's plug in 3, for example. 5, 3 minus 2 is equal to positive 5, which is indeed greater than 0. Okay, so 3 is part of the solution to this inequality. In general, what you do is you look for points of discontinuity. So your domain, think about your domain. What can I now plug in? Can I plug in 2? And you think about values where the function is equal to 0. And once you get those values, so for this one, I know x cannot be 2, so I have a point of discontinuity, a vertical asymptote, at the line x equal to 2. There's no other points of discontinuity, there's no other vertical asymptotes, holes in the graph. The other thing you would look for is x-intercepts. For this one, so to find your x-intercepts, you would set it equal to 0. And in this case, there is no value of x that'll give you a result of 0. And I'll list these steps in a second. So there are no x-intercepts. So you look for those x values. You would then write a number line. Make note of where those occur. So I have that 2. I'm only putting 0 as a reference point. There's no x-intercepts. Once you have this number line, you would test out the intervals before and after to see when the output is positive, greater than 0. So for example, I plugged in 3, I got a positive 5 for my answer. 2 is in the middle. I plugged in 1 and I got a negative answer. In fact, I got negative 5. So that tells you it's positive everywhere over here. As long as x is greater than 2, the output is positive, therefore greater than 0. So that is the general, what you need to do in general. Find the intercepts, x-intercepts, I'm sorry, vertical asymptotes and holes, list all those x values on your number line, and test out the intervals to see what kind of output you get, positives or negative or whatnot. Okay, so the answer to this one was x greater than 2. That one's done. There is your answer. If you want an interval notation, it would be from 2 to infinity, not including 2. All right, so let's clear this out. And we're going to work on number 2. All right, so here are the steps. So step 1, set one side to 0. Okay, so set one side to 0. So for this one, I need to subtract x. So I'll have my 0 on the right. Over here, I have x squared minus 3x plus 2 over x minus 3 minus x. All right. Step 2, rewrite, in this case, the left side as one fraction. All right. So in order to do that, we need a common denominator. So let me zoom in, more space. All right. Let's get back over here. So it's going to be quite a process. Okay, so 0 is over there. That's great. Over here, I have x squared minus, not plus, minus 3x plus 2 over x minus 3 minus x over 1. I need a common denominator, so let's go ahead and multiply by x minus 3. All right, common denominator is x minus 3. I'm going to put that fraction together. Let's kind of clean up the top part. Distribute this x here, so x squared minus 3x. This minus is going to apply to both of those, so be careful with that. So x squared minus 3x plus 2, I'm going to distribute that minus. So minus x squared minus 3x, so plus 3x. This one's going to actually work out really nice. You can see a lot of things cancel. X squared minus 3x plus 3x. So we are now left with 2 over x minus 3 is less than 0. All right. So step 2 is done. Quite a bit of work to deal with. Step 3. What do we need? Find x-intercepts. What else do we need? Points of discontinuity, so vertical asymptotes, and holes. So long story short, set the numerator equal to 0. That'll be for your x-intercepts. This never occurs, so there is none. Set your denominator equal to 0. That's for vertical asymptotes or holes if the factor were to cancel. So x equal to 3 is when the bottom is 0, it does not cancel. This is actually a vertical asymptote. All right. So once we have that, step 4, draw a number line and test out the intervals. Draw a number line. Use your values from step 3, which is just the number 3, and plug in. we're just going to plug into our 2 over x minus 3 to test out whether we get a positive result or a negative result. In this case, we want less than 0. We want negative and negative output. Go back, verify we're good. Yep. All right. So make your life easy. Just pick 4 right after it. Don't pick a much larger number. On the other side, it's up to you. 2, 1, or 0. I'm going to plug in 0. That's a lot of times easy to work with. I'm plugging these into 2 divided by x minus 3. So 2 divided by 0 minus 3. So negative 2/3. So this entire interval will be negative. Let's plug in 4. Over 4 minus 3 is 2. That's a positive answer. This entire interval will be positive. We want negative values only. So our inequality, that's been simplified, is less than 0 over here for all the x values that are smaller than 3. So our solution is x less than 3. If you want to double check your work, pick numbers less than 3, plug back into this original function. In fact, let's do that real quick. I'm going to plug in 2. I'm going to put 2 there, 2 there, 2 there, 2 there. 2 minus 3 is negative 1 on the bottom. 2 squared is 4, minus 6 is negative 2, plus 2 is 0. So yeah, 0 is less than 2. It checked out. So there are those two. All right, so to summarize this, the steps, set one side equal to 0. Rewrite the other side as one fraction. Get a common denominator, do what you have to do. Once you have that fraction, find the x-intercepts, vertical asymptotes, and holes, which are the x values that the function is neither positive nor negative, but everywhere else it will be positive or negative. Once you have those values, in this case it was just 3, everywhere else will have some value that you can work off of, and you test out the intervals by plugging in x values. And in this case, we found out it was negative on the left side of 3 when x is less than 3. So that is 1 and 2 for inequalities.